Now we have two equations, y equals 3x minus 5, y equals 1/3 x, that 1/3 might be a little hard to read, plus 2, 1/3 x plus 2. We want to find the point of intersection. Well, the first thing we can do is we can sketch graphs of these 2 points, two lines. This line has a slope of 3, a y-intercept of -5. So we go down to the y-intercept, which occurs on the y-axis at -5. And then the slope is 3, so we could move over 1 unit and up 3 and get a point, and then we can sketch a line. Okay? Then we can do the same sort of thing here. The y-intercept is 2, so the thing is going to intercept the y-axis here. And the slope is 1/3. So what do? To get a slope of 1/3, we can move over 3 units and up 1. It should be very clear that if we have a run of 1, 3, and a rise of 1, our slope is rise divided by run 1/3. So I did that. Now, my y scale and my x scale aren't the same, so these things don't look exactly like they would if we had equal scales. Both graphs would be steeper. But this is the way I happen to draw it. Okay. Now, where do these points cross? Or where do these lines cross? They cross right here. So I could estimate the coordinate where this one crosses. It's a little less than 3. And the coordinate, that's the x-coordinate, and the y-coordinate is also a little less than 3. So it's kind of close to the point 3, 3, but it's a little less than 3 here, and it's a little less than 3 here. So let's see if it comes out that way when we figure out where the point would be if these graphs were completely accurate. Okay, so the intersection occurs when the y-coordinates are the same, because at this intersection point, both lines have the same y-coordinate. They also have the same x-coordinate, but we're going to use the fact that they have the same y-coordinate and use that to get an equation that we can solve for the x-coordinate. Well, if the y-coordinates are the same, then this y has to equal this y, so this expression has to equal this expression. That is 3x minus 5 has to equal 1/3 x plus 2. And I write that as an equation. Okay? If I can find the x value that solves this equation, then I can plug it back into either equation, and I'm going to get a y value that gives me the y-coordinate of the point. And of course, the x value I get will be the x-coordinate of the point. So we do this. We multiply both sides by the common denominator, 3. Now it's a common denominator, but it's the only denominator, so that's the only real useful choice. It's the most useful choice. And it's at least common denominator. Put the word common in parentheses because there's only one denominator. But in general, when you're solving any equation, if you have denominators, you multiply by a least common denominator. If you can't find the least common denominator, multiply by any common denominator. You'll get rid of the denominators. And that's extraordinarily important. It's something I would hope everybody would come to this class knowing, because I'm sure it's stressed. But it's kind of difficult to master algebra, and people kind of tend to miss that whole idea. Save you a lot of time, so you don't want to miss it anymore. You want to lock that in this course. So we multiply both sides by 3. And that's going to give us 3 times 3x minus 5, 3 times 1/3 x plus 2. And then multiplying this out, 3 times 3x is 9x, 3 times -5 is -15. And then I'm writing out a little more explicitly the distributive law here, because there's a fraction involved, and fractions are underemphasized in our mathematics curriculum nationwide. Okay, so we write this as 3 times 1/3 x plus 3 times 2. Of course, 3 times 2 is 6. 3 times 1/3 is 3 divided by 3, which is 1. So that's 1x, and we just write that as x. So now our equation looks like this. Having multiplied through by 3, we no longer have to deal with fractions in the solution process, at least not to the very last step. So we take this equation, which would be a little painful if you try to subtract 1/3 x from both sides. transform it to this equation, where we just have to subtract x from 9x, and that's much easier, much less prone to error. So we rearrange this, subtract x from both sides, we end up with 8x here. Add 15 to both sides, we end up with 21 over here. So x is 21 over 8. So the lines intersect when x is 21 over 8, so that y is 3x minus 5, and that's going to be then, if x is 21 over 8, that's going to be 3 times 21 over 8 minus 5. Now, 3 times 21 is 63, so we have 63 eighths. 5 is 40 eighths, so we have 63 eighths minus 40 eighths. Well, 63 minus 40 is 23, so we end up with 23 eighths. Just to check, we're going to plug 21 eighths into here and make sure we get the same thing. That'll confirm that we really do have the point of intersection, the coordinates of the point of intersection. So 1/3 x plus 2, if x is 21 eighths, we then have 1/3 of 21 eighths plus 2. 1/3 of 21 eighths is 7 eighths, and 2 is 16 eighths. 7 eighths and 16 eighths, well, 7 and 16 is 23. We get 23 eighths. Same thing we got here. And if we did this algebra correctly, we would have to get the same thing both places, because our premise here was that this y is equal to this y, right? So our solution has to give us the same y, and it did. So our x-coordinate is 21 eighths, our y-coordinate is 23 eighths. Those will be the coordinates of this point. So we say the lines intersect at the point 21 eighths, 23 eighths. Now, is this reasonably close? Well, what's 21 eighths? 24 eighths would be 3. This is a little less than 3. 16 eighths would be 2, 24 eighths would be 3. This is closer to 3 than it is to 2. 23 eighths is even closer to 24 eighths. So the x-coordinate is a little less than 3, and there it is. The y-coordinate's a little less than 3, and there it is. Now, the actual x-coordinate would be a little closer to halfway between these points, would be about here. And if I projected this one correctly, it'd actually be a little closer to this. So things are off by a fraction of an inch in this picture, but this picture makes it very plausible that this is the solution. This point is pretty close to the point that you would get if you plotted this.